Okay, so section 5.7, interpreting graphs of linear functions. One other thing that we actually also look at in this section is something we call x and y intercepts. And that's fancy terminology to mean, that means where the graph crosses the x and y axis. Okay, and we'll get to that in a moment. So 5.7, interpreting graphs of linear functions. This lesson focuses on the use of intercepts, rate of change, domain, and range to describe a graph of a linear function. Determine the vertical and horizontal intercepts of the following graph. Find the domain and range for this function and the rate of change. This graph shows how the height of a burning candle changes with time. So here we have our nice fancy graph. We've got a great title. We have labels with units, and a great scale, points plotted, lines drawn. Okay, all of the key characteristics of a graph, which I hope you know after doing the 5.4 assignment, 5.4 graphing assignment. Okay. On the vertical axis, the point of intersection has coordinates 0, 10. So on this vertical axis, okay, this point of intersection, the point where the graph touches that vertical axis, this has a special name. The name of this point is called the y-intercept. Y-intercept. Where does that graph cross that y-axis or that vertical axis? So just reading through here, it says on the vertical axis, the point of intersection has coordinates 0, 10. This point is the y-intercept and represents the height of the candle before it is lit, 10 centimeters. So at 0 time, that's how tall that candle happens to be. Okay? It's called the y-intercept. This point actually has some coordinates. The coordinates of this point would be 0, 10. Okay? And those coordinates will become important in a little bit, but let's move on. On the other side over here, on the horizontal axis, the point of intersection has coordinates 45, 0. There we are. This point is the x-intercept, where it crosses that horizontal axis, the x-intercept. And it represents the time it takes for the candle to completely burn, and in this case, 45 minutes. And again, this point also has coordinates, and the coordinates of this point would be 45, 0. So these 2 points are called the x and y intercepts. They're the points where that graph touches both the x and the y axis. Now, if you look at the coordinates of the points, they have a little bit of a similar characteristic. Okay? The y-intercept has an x value of 0. The x-intercept has a y value of 0. And that is true all the time for x and y intercepts. Okay? Always, always, always. And we're going to look at that in the next question, but I just wanted to point that out now. The domain of this function, well, we have definite endpoints. So we know that our domain is going to have some definite endpoints. For domain, that's our x-axis or our horizontal axis. What's our lowest value or left-hand side value? 0. Do our symbols. In this case, t is that axis. Symbols, and our highest value 45. There's your domain. Range, similarly, what's our lowest value? Well, our lowest value is 0, less than equal to h is the units they used, or the variable that they used, and it goes up to a maximum of 10. So there's your domain and range. So we've looked at domain and range. We've briefly touched on x and y intercepts. Now let's talk about rate of change. How fast does this thing change? So rate of change in our bubble here, rate of change for this function is negative since the height of the candle is decreasing over time. So graphs that decrease over time, go down over time, are negative. So a graph that looks like this is going to be negative. A negative rate of change goes down from left to right. A graph that looks like this, well, it goes up from left to right, is going to be positive. Okay, a couple of key little things to remember. So our rate of change here, definition of rate of change, is going to be the change in h, our height, over our change, oops, in time. Or in this case, well, if we just went with our x and y intercepts, it would be negative, it goes down 10 centimeters for every 45 minutes. So there's our rate of change, negative 10 over 45. We could reduce that to negative 2 over 9. Okay. In words, what we're looking at is the change in our vertical values. So this triangle, this means delta, the change in our vertical values over the change in our horizontal values, or vertical change over horizontal change. That's our rate of change. Okay, rate of change is the change in vertical distance over the horizontal, change in the horizontal distance. And in this case was negative 10 over 45. Okay. We'll do lots more work with rate of change because it actually has other meanings and we use it differently in some instances. But rate of change is how much something changes up and down based on how far it moves left and right in fancy terms, in layman's terms.